So, Assalamualaikum warahmatullahi wabarakatuh. My name is Riandi Aditia. I'm from international class, industrial engineering. And then today I'm gonna discuss about Simplex Learn. So, the first one is comparing between alternative variable log based for most of increased value of z. In the example of the cases, it's like the maximizing the z by within the constraint, and then the function of z itself is for x1 plus 2x2, and then with this constraint. So first step is we are gonna change the ordinary form, this form, into the canonic form. So the canonic form itself, actually, we adding the select variable within our select variable is x3, x4, x5, and then in each constraint we added the select variable. Like for the first constraint we added the x3, for the second constraint we added the x4, for the third constraint we did x5. So after we change the canonic form, we can change the sign. Maybe pay attention at the first case. The sign is the less equal than, and then now if we already added the select variable, we will change it into the equal, just equal. And then next is write in the simplex table format. This is like the usual simplex table. As you can see, filling this table, it means that from the canonic table we transfer it the value of it, and then like you can see, this is the first constraint. Why? Because the x1 have the value of 1, so it's right at 1, and there's no x2 in the first constraint, so the x2 will be 0, and there's an x3 in first constraint, so it will become 1. So we fill up this table, part of table, and then at the top of the table is our z function within like the 42000 is like 42000, and then this is the select variable that we already added, is the x3, x4, and x5 within the value 0, and then the result value is the 2, 3, and 2. We just write it down as usual, and then we we just transforming, and then with this type of objective function, this is the filling initial simplex table. See, this is the simplex method in tabular form, the inner product from vector CB, and the constant so the Z is the result of the inner product. And then checking optimality, inner product from CB, and the column that relates with the XG in the canonic system. So it's the example of inner product. So still same with previous table. Yep. Now we're gonna fill it the row C. So the value of 4, it came from 4 minus 0 times 1 plus 0 times 1 plus 0 times 0, so it became 4. Same like before, for the x2 row, for the x2 column, It using the same method, so the value of 2 will become from 2 minus 0 times 0 plus 0 times 1 plus 0 times 1. So we do in the column x3, x4, and x5 within still giving the z value 0. And then what now? If you pay attention, because the CB is still 0, so the row C will still have the same amount as the Z function. So this is the just how to fill the row C, and then determine the entering variable. Determination of the variable that entered on base. Variables were selected to go into base. Variable are on the increase per unit on the Z greatest non-base variable that have the greatest relative value of the objective function. So it means that we determine it by the case of maximizing variable that enters the base, variable within the most positive relative objective function, increase the value of Z. It means that you can see this 4 is the biggest value among the others. So we will pay attention to this column. And then determine the variable out, determine the base variable that replace living variable with the minimum ratio rule. So like 4 is the biggest number. So we will pay attention at this column, and then we will divide the constanta within this column. So 2 divided by 1 will become 2. 2 divided by 1 will become 3. And then 2 divided by 0, we know the answer. And then after that, we choose the minimum positive value, which means that it is 2. So this x1 will enter the basis, substitute the x3 that will leave the table. Like this is just the example. Okay, this is a different example. So like, if you can see, this is the greatest number. Okay, and then the same like before, we divided by 3, we divided by 2, we divided by 1, we divided by 1, and then the minimum value is 1. So this is our point mark, and then this value will remain 1, and the other in the x2 column will become 0 by the iteration. Mark which column are entering the base. See the logic of C bar, determine the limits value for each constant in the column by dividing the constant within the column that have been selected. Determine the line comes out of the result of the smallest basis based on the smallest divided value. So this is the previous table. Now, like I said before, this still remain 1, and then the other became 0. So you can see, and it is changed the others row value. You can see, like before, this is 1 1 0 0, and then now it becomes 4 1 0 minus 3 0. So it calls the iteration. So how we can do that? By adding or eliminating or like giving minus to each row. We do the operation to make this is the 1 value of 1, and then 0 and 0. So now you can see the x2 is become the basis. So this is the he is the, or it is the entering variable. This is the 3, and the value of z is increasing by 3. And then the pivot operations, same like before. After that, you can see the greatest value is 5, so we will pay attention at this column, and then same like before, the 3 is divided by 4, the 6 divided by 4, and then the 1 divided by -1, the 1 divided by 1, and then so the smallest value is the 3 divided by 4, right? So this is our new point, and then it will change or must be changed into 1, and then the others like before change into 0. It's become 0, become 0, become 0. So tada, it's becoming 1 and 0 and 0 and 0. Now because because this is from the x1 column, so the x1 will enter the basis, right? And the value will enter the basis too, like 2, and then the z value will increase. And now we didn't stop there because there's still the positive value amount, and then we do the same thing again by dividing it a constanta within the column, and we'll produce, this is our point, and then it will remain 1, and then the other will become 0. Yep, you can see, guys, see the x5 will enter the variables, okay, within the value of it also. And now the z value will become 9, and maximus value already optimal because all row is minus or 0, and the solution is x1 is 3 and x2 is 1 within the value of z is 9. You can see row C is already minus or 0, and then no positive value, and of course you can see the x1 value will be 3, the x2 value will be 1, and then the z result, it came from x1 times 2, 3 times 2, which means 3 times 2 plus 3 times 0 plus 1 times 3 plus 1 times 0, okay? So it will become 9. So this is the problem for minimation. Just reverse it for the minimation. We will find at the first iteration the value will be already positive, all negative, and then we want to make it positive. So it's the reverse. If like this one, we try to make it in the maximize it, we try to make it the row C is negative over 0. In the minimize, we try to make it 0 or positive. So there will be no minus in the minimize case. Then after that, the solution of the problem minimize is therefore, to minimize the problem, only the non-basis variable that has a coefficient of relative negative objective function qualifies as a candidate variable that enters the basis. If maximization, choose the biggest positive value. The variable that enters the base entering the variable is a variable that has a coefficient of relative objective function most negative. So that the optimality condition minimize problems occur if all the coefficient of the objective function value relative known basis variable is not negative. If maximization, optimum when all coefficient objective is in negative condition. So the solution of the problem minimize is another alternative for solving the problem is to minimize is to convert them into the problem solving to the maximize the simplex method to maximize the problem. The conversion is done by multiplying the object function to the minimize problem within -1. So I guess that's all for me. I hope you guys get the new knowledge about simplex in the tabular form and how to build it, how to solve it, how to work on it, and then I hope you guys enjoyed the video. Thank you for watching and listening. Wassalamualaikum warahmatullahi wabarakatuh.